Good morning, everyone. Welcome to Principles of Information Security. We had already discussed about access control mechanisms or access control metrics and what you mean by access control. Today in this class, we can study access control policies. We have three types of access control policy. One is DAC, other one is MAC, then RBAC. So what is DAC? DAC is discretionary access control. What it means? It is actually a user-oriented security policy. That means it is based on the identity of a requester. For a particular resources, there will be an owner and the owner can decide the permissions or access rights. Okay, the permissions are set at the discretion of the resource owner. Resource owner can have the ultimate power to set the access rights or set the permissions. That means an entity has rights to enable another entity to access a resource. That is actually discretionary access control. It is purely user-oriented security policy. And another one is MAC. That is mandatory access control. Here, the resource owner has no role, but the system itself design or it defined the access permissions. Here, the permissions are assigned by a central authority based on some central security policy. So, how it is assigned these permissions based on some security levels comparisons of the system resources. If that resources have a top security or it has a low security, based on that, system itself or the central authority of the system itself define the access permissions. There is no rights to set the permissions by the resource owner. Okay, an entity cannot pass on access rights to another entity. This is actually mandatory access control. So we have three types of access control. One is discretionary access control. Second one is mandatory access control. Discretionary access control is defined by the resource owner itself. If I am the owner of a particular resources in a system or particular file in a system, I can set the permissions to another entity who all can access that file. That is defined by the resource owner itself. That is discretionary access control. But the mandatory access control, in which the resource owner has no role for setting the access rights or permissions. The system itself defined access rights or permissions. In system, there is a central authority based on the central security policy. It can assign or it can define the permissions or it can define the access rights of a resources or objects. You had already studied what is subjects, what is objects, etc. Okay, here there is no right for the resource owner to set the permission. Also in this, an entity cannot pass the access right to another entity. And how the central authority is defining a set of permission based on some security policy or central policies or based on comparing the security levels of the system resources. Okay. And the third one is role-based access control, that is RBAC. For a particular system, each and every person has a different role. If you're considering your college, principal has a higher role, system administrator has a different role, and the staffs have different roles. Okay, so based on that role within a system, access rights are allowed. Okay, so comparing in our systems, we have different users. Based on the user's role, we can assign different access rights to different users. So you can see a figure. DAC, MAC, RAC or RBAC, that is role-based access control. They are connected, but in the central space that is not mutually exclusive. So you can now see the detailed level of discretionary access control. So in discretionary access control, the owner of this object specifies which subjects can access the object. This model is called a discretionary access control model because the control of access is based on the discretion of the owner. Based on the discretion of the resource owner, we can set the access rights to a particular object. Subjects means they are the users within the system and objects are the resources. So in most operating systems like Windows, Linux, Macintosh, etc. are based on DAC models or discretionary access control model. In these operating systems, when you create a file, you decide what access privileges you want to give to another users. If you are creating a file in a Windows system, you can set access permissions or you can decide what access privileges that you can give to another users when they access your file. Okay, you can lock the file or you can clearly set if it is a private file or a public file, etc. The operating system will make the access control decision based on the access privileges you created. That is actually discretionary access control. You can see in the figure resources. Server 1, server 2, server 3 are the resources and we have 4 users. You can clearly see in the picture that server 1, which can be accessed by user 1, user 2 and user 4. Okay. So based on the discretion of the resource owner can itself assign the access rights to particular objects. Here the permissions are set at the discretion of the resource owner. It's highly flexible policy when the permissions can be transferred. Here there is no central control is there. We don't have a central authority for setting the access rights. The system owner itself setting the access rights. Next one, mandatory access control. We had already discussed that mandatory access control is the access control policy which is set by the system itself, or the access rights are set by the system itself. Within a system, we have a central authority for setting the access rights or permissions based on some central security policies or based on comparing the security labels of the resources. We have different objects or different resources in a particular system. For each resources, we have the security level that will be set by the central security central authority, security authority. So based on comparing that security labels of the resources, the central authority itself assign the permissions or access rights to particular user. That is actually mandatory access control. So MAC is based on the security labels. So we have subjects and we have objects in a particular system. So subjects are given a security clearance or mechanism, and data objects can have given a security classification or security label. So based on the security clearance and based on the security classifications, the central authority can assign the access permissions. Actually, it tries to match the clearance of the subjects with the classification of object. We are cross-matching the clearance and the classification of the clearance of the subjects and the classification of objects by the central authority. Based on that, access controls are defined or access permissions are set. So this MAC model is usually used in the environments where confidentiality is of utmost importance. So where this MAC is implemented or in which environment we are using the MAC. Example is the military institutions because there is a need of higher confidentiality. So if you require a system with a higher confidentiality, the MAC model is used. And the examples of the Mac-based commercial operating systems are SE Linux and Trusted Solaris. So DAC is in Windows, Linux, that is the commonly used operating systems. But in the case of SE Linux and Trusted Solaris, we are using Mac-based access control mechanisms. So actually it is better security than DAC. Permissions are assigned by central authority according to central policy. Good fit within organizations with a strong need for central control. There is a central control, low flexibility and high management overhead. So the central authority has the full responsibility for setting the access rights. That is why the users have low flexibility within the system. Often it is linked to multi-level security system. Okay. And the third mechanism is role-based access control. Already we had discussed that role-based access control or RBAC, in which the access rights are set by based on the role of a user within a system. We have a system with a number of users, and for each user we have different roles. Based on that role, he can access the system resources. Here the permissions are defined based on the job authority and responsibilities within a job function. And operations on an object are invocated based on the permissions, and the object is concerned with the user's role and not the users. So in that we are dealing with the user. And for Mac, we are dealing with the resources based on the central authority and central security policies. And here we are dealing with roles of a user. So you can see a number of users within the system, and also we have roles, and based on the user and its role, we can assign the permission. So there is a need of user role assignment in the left hand side and permission role assignment in the right hand side. So how these roles are assigned and how the permissions are assigned within a system based on the number of constraints, there will be a role hierarchies. Based on that role hierarchies, we can assign the permissions to a particular user. So it is based on role, not the identity. Here the many-to-many relationship between users and roles. Roles are often static. Many organizations has the access control decisions on the roles that individual users takes on as part of organization. With RBAC, role permission relationships can be predefined, and the combination of users and permission tend to change over time. The permission associated with the role are more stable. Here, RBAC concept supports three main security privileges: least privileges, separation of duties, and data abstraction. So the access control in organization is based on the role roles that the individual user takes part of the organization. Actually, role is a collection of permissions. You can see we have users, we have roles and permissions. You can set a relationship between user and role. Also, you can set, based on that role, you can set the access permissions. Based on the constraints, we can set the roles as well as the permissions. Then you are maintaining a role hierarchy. Okay. So, can you see an example in the figure? That is, Alison is a bookkeeper for math department. She has access to financial records. If she leaves and Betty is hired as the new bookkeeper, Betty now has access to those records. So within a system, a user is there, that is Alison. He is a bookkeeper. So she has the access rights to financial records. If she resigns the job within that organization and the next bookkeeper, that is Betty, is hired as the new bookkeeper, and now the Betty has to access these records. So the role of bookkeeper is inherited here. So the role is inherited, not the identity. Identity of the users are different. Alison and Betty is a different person. But the role of the Alison as well as the Betty is same. So here the role is inherited, not the identity. So the advantages of RBAC, it allows efficient security management. Principle of least privileges allows minimizing damages, separation of duties constraint to prevent fraud, and it allows grouping of objects. It provides generality. It encompasses DAC and MAC policies. So these are all the advantages of the role-based access control mechanism. So in this class, you had studied what is DAC, what is MAC, and what is RBAC. They are the three different access control policies or access control policy models: discretionary access control, mandatory access control, and role-based access control. I hope you cleared that. Thank you.